in this video I'm going to talk about phasing problems. And let's start off with explaining what phasing problems are. When you have two identical waveforms and every sound that is made up of waveforms in one way or another. When you have two identical waveforms and you stack them on top of each other, so when the upper cycle is going up and the other cycle is going down, and you place them exactly on top of each other, they will amplify. That means that you will gain 6 dB of volume change. But what if you shift them 180 degrees? So that means when the phase of one sign is going up, the phase of the other sign is going down. That means that the volume will flatline. That means they will cancel each other out. That are phasing problems. That's the physics part of phasing problems. In this video I'm going to show you two really good examples to show you how quickly you can get phasing problems. I've opened up my DAW, and for the first example I have a bass line, and that bass line is on this track that I'm currently hovering over with the mouse. And this bass line is made up, I made it up in Serum, and it has just a sub oscillator that is just a single sine wave, and I'm gonna switch on a triangle wave later on. I open Pro C so you can see that the volume is just a flat line. When I switch on my oscillator A and I selected a triangle wave in oscillator A and I switch off the sub, I will get again a flat line bass line. And with flat line I mean flat lined in the volume kind of way. I noticed that you probably won't hear it on the speakers, but that's fine. That's why I show it to you on the screen, so you can see in volume wise what is going on. If you're listening on your laptop or the microphone of the camera won't pick it up because it's so low. So that's why I show you on the screen what happens volume wise. So I have two oscillators, the sub oscillator and oscillator A. Both have a flat line volume wise in dBs, but when I switch off both of them, you will see that there starts to happen a change. Now the volume increases, the volume is somewhat lower, the volume increases again, decreases, increases, decreases, and decreases again. What is happening here is phasing problems. When I stack two waveforms on top of each other, and in this example it's a waveform combined with a square wave, but there are points that are, when you look at the sine wave, that they will cancel each other out in the process. That's something you have to bear in mind. Bass lines especially are very, very fragile in that way that you can have quickly phasing problems in the bass lines because the frequencies are so narrow on top of each other. That's example number one. Let's show you example number two. When I have my bass line again, in my first track I will disable oscillator A, so I've now only the sub oscillator that is a sine wave, and in my second track I have again Serum but with again a sub, and I will show them both. I let them hear you both. When you look at the volume, and when I switch off one, you will notice that the volume decreases because it's only one sine wave, and the difference between that is 6 dB. When I stack them again on top of each other, those are completely in sync with one another. You gain 6 dB. But now what happens if I invert that sine wave? In Studio One there is a plugin called Mix Tool with which you can do that. And I'll show you. I will invert the left channel and I will invert the phase of the right channel. You will probably won't hear it stereo wise, but you can see it on the volume meter that there will be a change in volume. I will play that again. I will show you the Pro C again. This is the volume. Invert the left, invert the right, and you won't hear anything now. And also my Pro C on my main channel, on my master channel, won't output anything. And the reason for that is I inverted the phase.